Okay, so for this video, we're going to go over Unit 6B or Chapter 6B, Measures of Variation. So we're going to talk a lot about standard deviation. Kind of that's one of the main things. We're going to talk a little bit about box plots and range and so on. So one of the first things we're going to talk about is the range of data set. The range of a data set is the difference between its highest and lowest data value. So all you have to do to find the range is you just take whatever the biggest data value is, and then you take whatever the smallest data value is, and then you just subtract them. And that's all there is to it. Okay. So it's really not that bad. All right. So an example, I think I deleted the wrong slide. Sorry about that, guys. So an example of a misleading range is consider the following two sets of data scores for 9 students, which set has the greater range, and would you also say that the scores in the set are more varied? So here's the thing. If somebody thinks that because you have a larger range, it's going to mean that you have, this big spread of data, it actually is an incorrect way of thinking. So if we take, for example, the range of quiz 1, let me come over here. Range quiz 1. That would just be the highest value, which is 10, minus the lowest value, which is 1. So we have a range of 9. Okay, so you would say, okay, that's a range of 9. And now for quiz 2, we take the highest value, which is 10, and we take the smallest value, which is 2, and we get a range of 8. Okay. So now you might think, well, this one has the greater range, so the data is more varied. But you can see, obviously, that 1 is an outlier in terms of this quiz right here because every other score was a 10. So if you go into quiz 1, what would you expect your score to be? You would expect your score to be 10, okay? So the data is definitely not varied. It's all 10, okay? However, here, there's a lot of variation in the data, but the range is smaller. So that's how sometimes people misuse range is they incorrectly think of it as the greater the range, the more spread out the data is, or the more varied the data is, okay? Something we're going to talk about that'll lead us into box plots later on in this section will be quartiles. And I would just, if you want to think of a good way, think of quarters. Quartiles is a fancy way of saying that you have divided something into quarters. Basically, that's what you're saying. Okay. So what the quartiles do is they cut the data in terms of the first 25% of the data, the next 25% of the data, the next 25% of the data, and the next 25. So all the data combined adds up to 100%, right? All the data. And the quartiles divide it up into percentiles and, 25th, 50th, 75th percentile. That's what the quartiles mean. So the first quartile divides the lowest fourth of the data set from the upper 3/4. It is the median of the data values in the lower half of the data set. So this is a fancy way of saying the lower 25% or 1/4 of data values. Okay. The middle quartile or second quartile is the median. So technically, you call this Q1. Technically, this is Q2, but nobody ever uses Q2. They just call it the median or just M. Okay. So we never really write Q2, even though it's quartile 2. Normally, we just call it the median. Okay. The middle quartile is the median. Okay. The third quartile, we could call Q3 for the third quartile. And this is the upper 25% or 1/4 of the data. Okay. So if you had 100 data values, this is saying that the top 25% of them, the top 25, are separated by this quartile number. Okay. That would divide the 25th percentile on top from the 75th percentile or the lower 75th. Something very important that we use quartiles with is to create the 5-number summary. Okay. And the 5-number summary for data set consists of the following 5 numbers: the low value, the lower quartile, the median, the upper quartile, and the high value. What I oftentimes call this is the minimum. Okay. And this the maximum. Okay. From statistics. And this is Q1. This is M for the median, and this is Q3. So this makes up the 5-number summary, these 5 things, okay? So we're going to use these to create a box plot. Box plots are created from the 5-number summary. Okay, and I'm going to show you how to do that. So before we move on, we're going to build our own box plot, okay, from scratch. All right, so let's get some data. Okay, so suppose we have this data over here, okay? So suppose we have 5, 10, 10, 10. How many 10s is it? 4 10s. Let's go 12, 15, 20, 12, 15, 20, 20, 25, 20, 20, 25, 30, 30, 40, 40, and 60. Okay. So what we're going to do, okay, what we're going to do is we're going to try to find the 5-number summary. Okay, so this will be part 1. Okay, and then part 2, we will create a box plot. Okay, so here's the thing. Now notice they're arranged in order, which is good because in order to find this, we need to first find the median. So what I always do when I'm doing these is I find the median first, okay? So let's see how many values there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I just wanted to make sure I copied it correctly. Now, the good news is because there is 15 data values, we don't have to do that little, the mean of the 2 middle values. So we're going to count 7, 1, 2, 3, 4, 5, 6, 7. And we're going to count 1, 2, 3, 4, 5, 6, 7. So we have 7 values to the left and we have 7 values to the right. So that makes this the median, right? Okay. So we now know, so let me write out our information. We want our our minimum. We want Q1 or quartile 1. We want the median or M. We want Q3 or quartile 3. And we want the maximum. Or I think in your book, they call it the highest value and the lowest value for the minimum. Okay, so we know the minimum value. What's the smallest value in this list of data? This is a 5, right? What's the biggest value in this list of data? 60, okay? And we just found the median is 20, okay? Now we have to find the middle values of this. So in order to find Q1 and Q3, what you do is you find the median between 5 and 20. So you find the median of that. So let's see how many values we have. 1, 2, 3, 4, 5, 6, 7, 8. So now we have an even number. Okay. Now the good news is we're going to get kind of lucky. Is that means that we're going to go 3 here and 3 here. Oops, sorry. 3 here, right? And then these 2 numbers, we're going to average them out and find what's in the middle. What's this middle number right here between the 2 of them? Well, luckily for us, the middle value of 10 and 10 is just 10. So I'm going to say that quartile 1 is 10, okay? So technically I would have done 10 plus 10 and then divided it by 2, which would have been 20 divided by 2, which is 10. Now we got to do quartile 3. So quartile 3 is we take 60 and we take 20, okay? Now let's go the other way. Let's go 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 values once again. So now we're going to take these 3 right here, and we're going to take these 3 right here, and we're going to find what's smack dab in the middle. So we need a number in between 30 and 30. Well, the number right there, the average of 30 and 30 is 30. So we get to say quartile 3 is 30. So what we're going to do then is we're going to draw a box plot. So what I'd like you to do is take out a piece of paper. Oops, that's a really crooked line. Sorry about that. So take out your paper, and hopefully you already have one out because you're taking notes, right? And start labeling it. And let's just start at 0, 10, 20, 30. And you want it to be somewhat evenly distributed. You are, I should say, spaced apart. You do your best to kind of make it look real. And then let's do 70. Okay. So now what we're going to do is we're going to draw a box plot. The way you draw a box plot is you literally take the values of the 5-number summary and you draw little like vertical lines. So for the minimum, you find the minimum. That would be right here at 5, right? So here's 5. And you draw like a little line, not a big one, okay? Then you find the maximum of 60 and you draw a little line right here at 60, right? Okay. Then what we're going to do is we're going to go to quartile 1, which is 10, and we're going to go draw a bigger vertical line. Okay, so we got 10 right here. I'll draw it even a little bit bigger. Okay, so there's quartile 1. Then we're going to go to the median at 20. Okay. I don't like the way that's turning out. Let's just do this. Let me just draw it nice like that. And then here's one at 20. And then now we do quartile 3 at 30. Okay. And you connect the dots. You connect all the lines and you create this. This is called a box plot. This is my min. This is my Q1. This is my median. And this is my Q3 for quartile 3. And this is my maximum. And that is all there is to drawing a box plot. Now, what you can tell, what the box plot is telling you is that the data here isn't very spread out. It's not varied. A lot of the data in the first 3 quartiles is very, I don't want to say very close together, but it's definitely close together. And then look what happens in this third, from quartile 3 to the max. So this is the top 75% of the data. That data is much more spread out, but that could be because 60 could possibly be an outlier. Okay, so that's something that that's when we start worrying about outliers, and we can discuss that later. So I just wanted you guys to see that's literally all there is to building a box plot is you find the 5-number summary. Okay, and once again, to find, oh, you know what? I think it says it over here. To find the lower quartile divides the first, it's the median. It is the median of the data values in the lower half of the data set. Okay, so you take the bottom half, the bottom 50%, and then you find the median of those 2 data values. So you do exactly what I did here. Okay, to find Q1, take the median. Geez, I can't write today. Median of the min to the median. Okay, so you have to take the median of whatever or median / Q2. Maybe that's a bad way to explain it. If you guys need, show up to class and ask me for help on this. To find Q3, maybe I should say find the median. The median between, I think that's a better way to say it, between the max value and the median Q2. Okay, and again, nobody really calls it Q2. It's normally called the median. Okay, so basically you have to find the median, and then you find the median again, and then you find the median again. So notice, between here and here, this guy right here is the median. Then between here and here, oops, I'm sorry, that's wrong. Between the median and the maximum, this guy is the median. Okay, so that's what we're doing here. We're just trying to find a bunch of medians of different locations, and that's how we build our 5-number summary. Okay, so let's go back over here to the notes. So here you see the 5-number summary of waiting times at each bank. Okay, so Big Bank, what they did was they showed you that this is the meeting time of 4.1 is the minimum value. The quartile 1 is 5.6. The median wait time is 7.2. Quartile 3 is 8.5. And then the maximum wait time is 11. Okay. Then you come over here for Best Bank. Right here, they're showing us for Best Bank and for Big Bank. And they drew them on the same graph to kind of get you to compare and contrast. Notice how spread out is all the data here versus the data here. Okay. So what the box plot is trying to show you is that if you notice, I feel like it's kind of evenly distributed right here, right? It looks like it's kind of good. Everything seems like it's spaced out about the same distance. And here, it seems like there's very little between the 6.6 and the 7.8. Which one of these banks do you think has more unhappy customers? Best Bank or Big Bank? Okay. I would think that Big Bank is going to have more unhappy customers because you notice it seems like this bank, all the wait times are about from 6.6 to 7.8. Everybody kind of knows what they're getting into when they come to this bank because, you know, the wait times from 6.6 to 7.8, the quartiles don't really show that there's a big, you know, gap between the min and the max and the quartiles. However, in this, look at the wait times, the min to the max, and then look how many people. Like you could be in the bottom down here and, you know, get 4.1 to 5.6 minute wait time, or you could end up being over here. Look at how drastic the change is. 8.5 to 11 minutes, right? So you never know when you go into this bank what you're going to get. So people are probably much more unhappy because they get these random wait times. Or I shouldn't say random wait times, but they get, you know, it's much more drastic in the change. In here, you kind of know that it's between 6 to 8 minutes, you know, somewhere in there, and there's really not a big variation in that. There's not a lot of spread, and that's what the box plot is trying to show you with it being so clumped up like this. Okay. Standard deviation is the single number most commonly used to describe variation. So standard deviation in statistics, that's like the driving force of my statistics class. We talk about standard deviation all the time in that course, okay? So standard deviation is the sum of the deviations from the mean squared divided by the total number of data values minus 1, and then all of that square rooted. Okay, so this is going to require a little bit of effort on our part. Here's the steps they want you to use. So it says compute the mean of the data set, then find the deviation from the mean for every data value. Deviations from the mean equal data value minus the mean. Find the squares of all of these answers, all of these deviations from the mean. Add all the squares up of the this is the sum of the squares of the deviations from the mean, and then divide the sum by the total number of data values minus 1. The standard deviation is the square root of whatever you got. So that seems pretty difficult. So I'm going to show you guys an example on how to do it by hand. Let me just get my notes out for this. I think I have a nicer one. That's not too bad. Yeah, let's do a nice one. So suppose, you know, that I give you the 3 data values, 1, 3, and 4. You know what, let me spread it out a little bit. 1, 3, and 14. Okay, so this is our list of data values. So this is, let's say that this is find the standard deviation of wait times from a random sample at a grocery store line. Okay. Now, first things first, standard deviation is calculated by completing this, but I want you guys to kind of think about they don't really give a good definition of what the standard deviation is. The standard deviation is basically saying how far away from the mean you are, okay? Or how much, what percentage. Oh, no, that's not a good way to say it. Let me see. I have a dictionary definition of standard deviation. Okay. Okay, so standard deviation. I'm trying to explain it in not super technical terms, but I think this is the best way to kind of go from here. Standard deviation is a measure that tells the average variation of the sample data or data sample data values from their mean. So basically what it's telling you is it's saying that standard deviation is a way to represent your relative standing in accordance with the mean. So basically, how far away from the mean you are, or relative speaking, how far away is this particular value from the mean? Is it 1 standard deviation away? Is it 2 standard deviations away? Is it 3 standard deviations away? So on and so on. So let's see here. So first on I'm going to show you how to find it by hand. Okay. And it's a little bit of a process, but it's not too bad, especially if you don't get a big, large data set. So the first thing it says is to compute the mean. So we got to find the mean. Okay. And we know the mean is equal to 1 plus 3 plus 14 divided by 3, right? So that will become what? 18 divided by 3, which is 6. Okay. So this is our mean. So it says compute the mean of the data set, then find the deviation from the mean for every data value. And basically what you do is you take the data value and you subtract the mean. So I'm going to set it up like this, and I encourage you guys to do this as well. I'm going to do 1 minus the mean, 3 minus the mean, and 14 minus the mean. Remember, our mean was 6, so I'm just subtracting that. So let's see what we get. I get -5, I get -3, and I get 8, right? So that was step 1. Now we're on step 2. It says find the squares of all those deviations. So now what I'm going to do is I'm going to square this, I'm going to square this, and I'm going to square this. So now we're here, and this says I get 25, I get 9, I get 64. Okay. So then it says add all of the squares of the deviations from the mean. Okay, no problem. I can do that. So let's do this. Plus, and what does this equal? 25 plus 9 is 34, plus 64 is 98. Okay, so now we're there. Then it says divide the sum by the total number of data values minus 1. Well, the total number of data values was 3, so I'm going to do 3 minus 1. So this will become 98 divided by 2, which is 49. Okay. Now it says, so we divided that by -1. The standard deviation is the square root of this quotient. So we are going to square root this, square root that, and square root that. And we end up with 7. This is my standard deviation. So this tells us this is about how far the data is from the mean. So the mean is 6, okay? And in general, the data is, if you're 7 away from the mean, you're at 1 standard deviation. If you're 2 standard deviations away, you'd be 7 plus 7 away from the mean. So you'd be 14 away from the mean. Okay. And again, these values are pretty spread out. So it's kind of, the standard deviation is normally big. The standard deviation is a smaller number in comparison to the data when all the data is very close together. Okay. As you can see, 1, 3, and 14, like if this number, instead of being a 14 was like a 5, it would have worked out even nicer than that. Okay. I shouldn't say nicer. That's a bad way to think about it. It would have worked out as a smaller number. My standard deviation would have been smaller because the data values are closer together. Okay, so standard deviation is a way to talk about the data and how and the relationship and relative standing to the mean. Okay, So the range rule of thumb, the standard deviation is approximately related to the range of a distribution by the range rule of thumb. So this is not something I use a lot in statistics. I've seen it in a psychology statistics book, but I try to use the rule of thumb of 2 times the standard deviation plus or minus, or the mean plus or minus 2 times the standard deviation. But in your book, they want us to talk about the range, whatever the range is divided by 4. So if we know the standard deviation, so this is the one I use. This is the one I use in my statistics course. So that's what we're going to use in here. And this is the range rule of thumb for standard deviation. So let's try one. Let's see if they have one here. Okay, so studies of gas mileage of a Prius under varying driving conditions show that it gets a mean of 45. So we know the mean is equal to 45 miles per gallon with a standard deviation of 4 miles per gallon. So standard, I'm just going to write S for standard deviation from now on, of 4, okay, 4 miles. And this is miles per mpg, miles per gallon. Oh, and this is, I'm sorry, that's my fault. Let's just do mpg. Okay. mpg. Okay, so that's our mean and our standard deviation. So they want us to use now we can't do the range rule of thumb because they didn't tell us the maximum value or the minimum value, but they did tell us the standard deviation. So we could estimate the minimum and maximum gas mileage that you expect under ordinary driving conditions. So we got to go back up here. And basically what this is saying is that if we know the standard deviation of the data set, we estimate the low and high values. This is a fancy way of saying that this would be the minimum usual value. So this is the lowest we would expect, and this is the maximum usual value. So basically you take the mean and you add or subtract 2 standard deviations, and that should give you a window on what you would expect in terms of answers, or for this particular problem, what the MPGs would be, the lowest you would expect to get and the highest you would expect to get. Anything outside of that is possible, but it's very unlikely based on standard deviation. Okay, so let's find our low value. So our low value takes the mean of 45 and it minuses 2 times the standard deviation, which is 4. So we get 45 minus 8, which is 37. So we would expect to get 37 MPGs on the low end. On the high end, we would take 45, which is the mean, and add 2 times the standard deviation. Oops, I guess I should approximate. And this would be 45 plus 8, which is approximately 53. Well, they're saying that this is the approximate high values, MPG. So we would expect when we're driving this car to get anywhere between 37 and 53, and that would be considered usual, okay? Anything outside of that would then become unusual, all right? So that's how we can talk about the rule of thumb. Let me see if I have another one for you guys in my notes that's a little bit nicer. Okay. I wouldn't say it's nicer, but let me give you, oh, that one's really tough. You need a calculator for that one. Okay. So, okay, so we're gonna just try to, I'm gonna give you, because not everyone in this class is gonna have a graphing calculator. So I don't want to give you one that requires a graphing calculator to do the 5-number summary. So what I'm going to do is I'm going to give you data values. So 3, 24, 30, 47, 43, 7, 47, 13. Oops. 13, 44, 39. Okay. So we have to arrange these in order. I want to just practice using the range rule of thumb. So let's arrange these in order from smallest to biggest. Okay. So we have 3. What's the next smallest? 7. You know, I'm not even going to use commas. We have 3. We have 7. What's the next one? 13. What is the next one? 24. The next one would be 30. The next one would be 39. The next one would be what? 43. Oops. The next one would be 44. The next one would be 47, and the next one would be 47. So 47 and 47. And I did use 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm not going to make, this is too many values to do by hand. I would use my calculator to find the standard deviation of this problem. So let's just say that we already knew the standard deviation. This is dietitians have obtained the amounts of sugar in centigrams from 100 centigrams in each of 10 different cereals. The values are listed below. So this is basically sugar content in terms of centigrams in cereal. So what we're going to do is I'm going to say, given in this particular one, just because we don't have a calculator, given the standard deviation S equals about 17. Okay. It's actually 17.017 centigrams, but I'm just going to round it off to 17. Use, let's go back to here real quick, you guys. Let me show you what I'm trying to show you. So the standard deviation is approximately related to the range of the distribution by the range rule of thumb. So we can approximate the standard deviation using the range rule of thumb. Let's see how close it is. So from the calculator, this would be about 17.017 if you wanted to use your calculator. Let's see. Compare this to the range rule of thumb. Compare the actual standard deviation to the range rule of thumb. So I want to basically say, find the range rule of thumb standard deviation, or use the range rule of thumb to find the standard deviation and compare it to the actual standard deviation. The actual standard deviation is actually 17.017 rounded to 3 decimal places. Okay, but just for purposes of this, let's just call it 17. So the range equals 47 minus 3, which is 44. Okay, so that's our range. The range rule of thumb says you take that. So we're going to take range rule of thumb for standard deviation. The range rule of thumb for standard deviation says that you take the range 44 and you divide it by 4. So we would get approximately 11. So according to the range rule of thumb, you take the range and you divide it by 4, and that's supposed to give you the standard deviation. So as you can see, like I said, in my statistics course, we don't use this very often, but I have seen this used before, and it's quick. Like it definitely can kind of give you a good idea, but this is not really a good for this particular problem. And again, it also depends on the data set you're using and how spread out it is. But again, that's going a little too deep into it. For problems. I'm assuming if the data was normally distributed, that this would probably be a better indicator. But anyway, I would say that finding the standard deviation using the sum of the squares, like I showed you here, you should do this. And if I ask you a question on the exam, it would be in a smaller data set, so you could do it by hand. I wouldn't give you like 10 or 20 values that you had to do that. But you do need to know how to use the range rule of thumb, because it's going to be in your homework and also might be a test question. And this is definitely something that I'll ask you on the exam is this is also known as a rule of thumb. So this is also a rule of thumb for, let me write this better. Rule of thumb for usual and unusual values. Okay. This is how you can determine if something's usual or unusual. Is if it's outside of this window that you created, you'd call it unusual. If it's inside of that window, you would call it usual. Okay. But that's going to do it for this video, about 35 minutes. So thanks for watching, you guys.